You're most welcome to the third episode of Atomic Structure, Periodic Table and Bonding. Today we are going to focus on the periodic table, such that we arrange the first 20 elements according to the periods and groups to which they belong to, and try to respond to a few questions which will open up a door on bonding and what we are supposed to write when it comes to that particular area. The periodic table shows us how different elements are arranged in terms of groups and periods. And if I can try to remind you, the first 20 elements included hydrogen, represented by capital H. We had helium, He, lithium. We had beryllium, boron. We had carbon, nitrogen. We had oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, sulfur, silicon. From silicon, we are going to phosphorus, sulfur, chlorine, argon, potassium, and calcium. These were the first 20 elements. First 20 elements in order of increasing atomic numbers. Then there are elements which we didn't talk about. However, we are going to call them transition elements, elements which form compounds that are colored, so on and so forth. Among them, we have scandium, titanium, vanadium. We have things like cobalt. We have iron. We have nickel. We have manganese. There is copper. There is zinc, among others. So all these ones are part of elements we are going to be calling the transition elements. So it comes to the periodic table. If this is our periodic table, we are going to find out that this periodic table has different groups. We have group 1. If I try to draw the table clearly, group 1 has only elements which have only one electron in their outermost shell. Group 2, like we agreed last in the previous episode, will have elements which have 2 electrons in their outermost shell. So if I'm to put an element, which is the very first element in group 1, we shall find hydrogen, capital H, with atomic number 1. This hydrogen is going to be found in period 1. When we enter period 2, we shall have period 3, and lastly period 4. And these periods will show us the different elements present in different groups. So if this is group 3, we shall have an element there. We try to represent the transition part of the periodic table. This is group 3. From group 3, we shall move to group 4. We shall find group 5. We shall find group 6. Group 7. And lastly, we shall find group 8. So when we complete our periodic table in case of a drawing, we shall have something to do with all to appear in this structure. Different periods having different elements and different groups possessing different elements, and we are trying to place our atoms within the periodic table. Trying to again represent these elements with their electronic configurations, we shall realize that hydrogen had 1, helium had 2, lithium was 2 to 1, beryllium 2 to 2, boron 2 to 3, carbon 2 to 4, nitrogen 2 to 5, oxygen 2 to 6, fluorine 2 to 7, neon 2 to 8, sodium 2 to 8 to 1, 2 to 8 to 2, 2 to 8 to 3, 2 to 8 to 4, 2 to 8 to 5, 2 to 8 to 6 for sulfur, 2 to 8 to 7 for chlorine, 2 to 8 to 8 for argon, 2 to 8 to 8 to 1 for potassium, and 2 to 8 to 8 to 2 for calcium. Now, when it comes to group 1, we only pick out those elements which have 1 electron in the outermost shell. And the number of shells you have determines the group where you belong to. Our first has been hydrogen in group 1, and since it has only 1 shell, we have placed it in group 1. Next in group 1, we are going to find lithium. Since it has 2 shells, we shall find it in period 2 with atomic number 3. We go down till when we find an element with only 1 electron in the outermost shell. That becomes sodium, which has 11 as the atomic number, found in period 3. And lastly, in these first 20 elements will be potassium, which has atomic number 19. From there, I'll look for elements which belong to group 2. Elements which belong to group 2. This one has 1 shell which is fully filled, so it cannot be in group 2. I'll begin with beryllium, which I'll put in period 2, simply because it has 2 shells. I'll meet magnesium with an atomic number of 12, placing it in group 2. In period 3, because it has 3 shells and 2 outermost electrons. Then we meet calcium, 1, 2, 3, 4 shells makes calcium to belong to period 4, and the fact that it has 2 outermost electrons makes calcium to be under group 2. We are going to place those of group 3, beginning with boron, which has atomic number 5. From boron, the next we are meeting is aluminium, atomic number 13. It has 3 shells. That's why I'm also putting it in period 3. Then among the transition elements, these ones are many. We shall find the scandium, titanium, the vanadium, cobalt, iron, nickel, manganese, copper, and zinc. Those are some of the transition elements we know. And commonly at O level, we are going to see these as transition metals or elements. Group 4 begins with an element with 4 electrons in the outermost shell. Therefore, we are meeting the first element as carbon in group 2. Atomic number is 6, which is 2 to 4 electronic configuration. The next we are meeting is silicon with atomic number 14. The rest are there, but we don't put much focus on them. There is germanium, there is tin, there is lead under group 4. But when we are discussing the chemistry of the periodic table, we tend not to focus on them because of the high atomic numbers, which will increase the number of shells they possess. Group 5 will allow us to go to elements that have 5 electrons in the outermost shell, beginning with nitrogen, atomic number 7. We move to phosphorus, atomic number 15. Then group 6, we are going to find there elements like oxygen coming first, atomic number 8, and sulfur, atomic number 16. Group 7, we shall meet elements like fluorine, atomic number is 9. We shall meet chlorine, atomic number is 17. There are other elements which we don't put much emphasis on writing the electronic configurations. For example, iodine, bromine, among others. Lastly is group 8. These ones should be having fully filled energy levels. So as long as the energy level is fully filled, you put it under group 8. For example, helium, only 1 shell which is fully filled, helium with atomic number 2. From helium, the next we are meeting is neon, atomic number 10. We shall meet argon, atomic number 18. There are very many others which we can add on, but periodically, that is our periodic table in simple terms. Majority of these metals have specific names. If you belong to group 1, we call you alkali metals. If you belong to group 2, we call you alkali earth metals. If you belong to group 4, we normally give them a name of metalloids because it is a transition from the metallic side to the non-metallic side. Group 7, we are going to normally call them halogens, and group 8, they are going to be inert, all noble gases. So that is our periodic table. Each group has different characteristics, and the periods also have different characteristics. However, we can go through those few characteristics of generally the groups and the periods, such that we can understand the concept of the periodic table. So periods, I'm beginning with periods. These periods are written in numbers, i.e. 1, 2, 3, 4. Number 2, if you follow the periods, atomic size decreases across the period. What do we mean? As you move from hydrogen from group 1 to group 8, size of atoms reduces. That is atomic size across a period. Next, non-metallic character increases across the period. As you move from group 1 to group 8, this is across the period. You move away from elements we call metals. Those are elements found in from group 1 to group 3. We shall call them metals. Then from group 4 onwards, we shall call them non-metals. So as you move from group 1 towards group 8, you increase chances of finding non-metals. That's why we are saying non-metallic character increases across the period. When we look at the groups generally, groups, we shall find out that they are written in Romani numerals, i.e. group 1, group 2, group 3, group 4, among others. They are going to be determined by the number of electrons in the outermost shell. For example, you have 1 electron in the outermost shell, you belong to group 1. If I rate you as 2 to 8 to 1, you belong to group 1. I rate you as 2 to 8 to 2, you belong to group 2. Simply because the number of electrons in your outermost shell represent the group to which you belong. Atomic size increases down the group. Therefore, if I consider group 1, potassium is bigger than hydrogen, simply because potassium is below hydrogen when it comes to the group. As we continue to discuss more characteristics of elements in particular groups, you will find out that number of shells increases down the group. So as you move from hydrogen to potassium, you increase the number of shells around the nucleus of an atom. Atomic number increases down the group, among others. When we enter the individual groups themselves, you will find out that if we classify an element in a particular group, those elements will be having similar characteristics, similar chemical properties, because they are under the same group in the periodic table. For example, if I try to look at the characteristics of group, I'm going to look at the characteristics of a particular group here. Characteristics of group 1 elements. Remember that these elements have been hydrogen, we've been having lithium, there is sodium and potassium. These elements have 1 electron in the outermost shell. For example, hydrogen electron configuration is 1, lithium electron configuration is 2 to 1, sodium electron configuration is 2 to 8 to 1, potassium electron configuration is 2 to 8 to 8 to 1. So 1 electron in the outermost shell. They have a valence of 1. Valence is the combining power. So sodium, potassium, lithium, hydrogen have a valence of 1. They are the most reactive metals, and reactivity increases down the group. What does that mean? Potassium, because it is at the bottom, is more reactive than sodium, and sodium is more reactive than lithium. Then lithium is more reactive than hydrogen, depending on how reactivity is put. Then next, react with chlorine when heated to form white solids of their chlorides. If you get sodium, you heat it with chlorine, which is a gas, you're going to get sodium chloride, which is a solid. And make sure that your equation is balancing. So what is formed here, sodium chloride, is what we call our table salt. And sometimes in solution form, we call it brine. If it is in solution form, it's what we put in our sauce such that it can become tasty. So the sodium chloride we use as our table salt is white. That's why we are suggesting that group 1 chlorides are all going to be white. These compounds, all these elements, react with cold water vigorously. So if I have my potassium, which is a solid, will react with cold water, which is a liquid, to form a basic solution of potassium hydroxide and hydrogen, which is a gas. Make sure that the equation is balancing. For you to easily balance such an equation, begin by making this oxygen to be in even number. So multiply water by 2, hydrogen becomes 4. You come here, multiply the hydrogen by 2, such that these 2 plus these 2, hydrogen has become 4. Potassium has become 2. That's why I'll multiply potassium by 2. We agreed that group 1 elements are also called alkali metals. Among all the metals in the periodic table, they are the most reactive, and we shall talk about their characteristics more. Still in group 1, atomic size increases down the group. That's why potassium is bigger than sodium. Sodium is bigger than lithium, and lithium is bigger than hydrogen, because atomic size increases down the group. When we handle group 2, group 2 elements known as alkali earth metals, we are going to find out that these metals include the following. We begin with the beryllium. From beryllium, we met magnesium. From magnesium, we met calcium. We are going to realize that all of them have 2 electrons in the outermost shell. If we come to writing the electronic configurations, beryllium is 2 to 2, magnesium is 2 to 8 to 2, calcium is 2 to 8 to 8 to 1. The different ways I'm writing my electronic configurations are allowed in an exam. That's why I'm trying to bring in the different versions I expect you to write an electron configuration in. Number 2, they have a valence of 2. So beryllium, magnesium, calcium all have a valence of 2. Next, atomic size increases down the group. These elements are less reactive than group 1 elements. However, reactivity increases down the group. Just like in group 1, calcium is more reactive than magnesium, and magnesium is more reactive than beryllium. According to that, react with chlorine to form chlorides. This is the same just like in group 1. So if I have calcium, react it with chlorine gas, you will be able to get calcium chloride, which is a white solid. Magnesium, react it with chlorine gas, you will be able to get magnesium chloride, which is also a solid. React with oxygen to form what we call basic oxides, mainly to form basic oxides. For example, if I have magnesium reacting with oxygen gas, I'll form magnesium oxide. The valence of magnesium is 2, that of oxygen is 2. So the compound formed will be magnesium oxide. We balance by multiplying here by 2 because oxygen is 2. Therefore, magnesium will also be multiplied by 2. So those are some of the characteristics of group 2. We shall go to group 7 elements, also known as halogens. These ones include fluorine, chlorine, bromine, then iodine. When you look at them, they have 7 electrons in outermost shell. For example, fluorine, electron configuration is 2 to 7. Chlorine, electron configuration is 2 to 8 to 7. When we continue, they have a valence of 1. These substances or compounds exist as diatomic molecules. What do we mean here? Fluorine, when you're writing fluorine, it will be F2. Chlorine will be Cl2. Bromine will be Br2. And iodine will be I2. That's why when I was writing chlorine here, in this section, I wrote Cl2 because it should exist as a diatomic molecule. Next, reactivity decreases down the group. What does that mean? Fluorine is the most reactive halogen, followed by chlorine, followed by bromine, and lastly, iodine, in that order. And we shall also say that they are the most reactive non-metals. Those are group 7 elements. Form negatively charged ions. Such ions are called anions with a charge of 1. Some individuals will say with a unity charge. For example, fluorine will form an ion of F-, chlorine will be Cl-, bromine will be Br-, iodine will be I-. So those are some of the general characteristics of the different groups in the periodic table. In this video, I would like to end there and request you to continue subscribing to my channel. Like, comment, and share the link to other members out there, such that we can increase the study of chemistry and how we can excel it. I would like to stop here. I wish you the best. Thank you.